The ideal vapor compression cycle can also be plotted inside the pH diagram, and it's even more common. This is due to the fact that it's pretty handy to have these state variables on the axis, because we have two specific pressure levels inside the machine, and also we have one of the transformation that is at constant enthalpy. Moreover, then when we want to do the energetic analysis of the cycle, we will care a lot about the specific enthalpies of the different points of the system. So it's useful to have the specific enthalpy easily available on the x-axis. So if we want to draw this cycle on a pH diagram, first thing to do is to draw the two specific pressure lines, so the low pressure and the high pressure of the cycle. We have seen that point A is located in this ideal cycle as saturated vapor at low pressure, so point A would be there. Then from A to B we have an adiabatic reversible, so isentropic transformation, and the isoentropy line are banded this way in a pH diagram. So that's the specific entropy that we have in point A. So in that case, we will follow this isoentropy line until the high pressure where we have point B. Then from B to C, it's an isobaric heat exchange until being saturated liquid. So point C will be there, and that's quite easy to see what's happening inside this heat exchanger. It's just following the isobaric line at high pressure, and of course the specific enthalpy is decreasing, so that the specific entropy too, because the working fluid is giving heat, so it's giving enthalpy, and it's also giving entropy to the secondary fluid, which corresponds to the hot source. Then from C to D we have an iso enthalpy transformation. So we can plot vertically the enthalpy of point C, that would be the same than the specific enthalpy of point D, and point D will be at low pressure, so this is what is happening inside the expansion valve. And then finally from D to A there's a heat exchange where the fluid is evaporating until being a saturated vapor, and this is taking place at constant pressure until point A. And easy peasy. Maybe we can just add here, just for information, the ISO temperature line, at least for the condensation temperature and for the evaporation temperature. So the ISO temperature line are horizontal inside the two-phase zone. So for the evaporating temperature this way, it will be vertical here in the liquid zone and with a shape like this, so that's T evap in the vapor zone. And similarly we can plot here the condensation temperature T1. So like this, it's pretty obvious that point B is not at the condensation temperature, but at a higher temperature than the condensation temperature. So this is the ideal vapor compression cycle in a pH diagram.